Hello, my name is Luke Cronin, and today I'll be going over part 3 of my ECE 5000 design project, which is the implementation, where I'll be going over a working prototype and first version of my code for my Bluetooth controlled garage door opener. This garage door opener can be controlled through a Bluetooth device, through a mobile app, or it can also be controlled using the conventional way, which is just a simple push button. The device features a relay module, a Bluetooth module, a push button, an LED, an Arduino Uno, and some resistors. In the next part of this video, I'll be going over the circuit shown here through the fritzing schematic, and I'll also be doing a demonstration of the device and going over how the app was made, going over the code, and going over this circuit itself and each of its parts.
So to begin, I'll just walk through the circuit here on my breadboard so you can better see kind of the physical circuit and how I connect everything. So starting off, we have the push button here, which allows for the manual control of the device. So if you don't have a device through Bluetooth, you can just still control the garage door the way it always would be. So I just have a simple push button set up, so I have a pull down resistor to ground, and then the push button is connected to pin number 2 on the Arduino. And there's a lot of wires here, but this circuit can be seen fully in the fritzing schematic. And next I have the actual Bluetooth module. So the Bluetooth module has TX pin, an RX pin, a ground pin, and a VCC pin. So something with the RX pin on the Bluetooth module is that it can only receive 3.3 volt signals, and since the Arduino outputs a 5 volt signal, we have to use a simple voltage divider with a 1K and a 2K resistor, which can be seen right there, to step down the voltage from 5 volts to 3.3 volts, and then that can be fed to the RX pin of the Bluetooth module. So that RX pin connects to the TX pin of the Arduino. Then the TX pin of the Bluetooth module connects to the RX pin of the Arduino. And then we just have ground and VCC connected to ground, obviously, and then 5 volts to actually power the device. Next, we have a blue LED, which acts as the Bluetooth indicator LED, as mentioned in this document and the previous deliverables in this course. So what this does essentially is just lets you know when your device is actually connected through Bluetooth. So when a successful connection is made, this blue LED will illuminate, indicating that there is a connection, and then when you disconnect, it'll just turn off. And then just that is connected with a 220 ohm resistor and is connected to pin 8 on the Arduino. Next we have the relay module. So the relay module, this is actually a 2-channel relay module, so there is 2 channels, but we'll only be using 1 for this project. So there are ground pins, 2 in pins, which control each channel of the relay, so we're only going to be using IN1, which can be seen right there, and then a VCC pin, which actually powers the relay and the integrated circuits on this module. So we just had the VCC connected to 5 volts, the ground connected to ground, and then IN2, which goes directly to the Arduino, which in our case is pin 13. So the Arduino will just either set the relay high or low, depending on what the code tells it to do. And lastly, so as again described in the last 2 documents, and a brief description will be provided in this part 3 submission, is that most garage doors operate by waiting for a short pulse through 2 wires that are connected directly to the garage door. So to demonstrate that without a garage door, I'm just going to be hooking up an LED to the relay, so that when a signal is either obtained through pressing that button or through the Bluetooth app, this LED will illuminate for a short period to just try to simulate that short pulse that would be sent to the garage door. And then an actual working demonstration will be shown later in this video. And then lastly, everything on this breadboard is just powered by the 5 volt and the ground that is on the Arduino itself, which can be seen right here. And then this ground is just for providing a ground reference to the other rail on the opposite side of the breadboard. So now I will do a complete working demonstration of the device itself. Again, not using a garage door in this part, but this short pulse shown through the LED will simulate the garage door either opening or closing. Again, which will be shown later in the video. And right now I just had the Arduino powered through a USB cable plugged in directly to my computer. But again, in the final version, this will be obviously connected through a power device or a battery. So to begin, the device, a Bluetooth device, is not connected to the module, which can be shown through this LED not being turned on. And just to show that the device does work without a Bluetooth module, I'll press this button and you will see that the LED will illuminate for 250 milliseconds, which is a short enough pulse for the garage door to open or close. So the button works, and to actually connect the device, you will just go to your Bluetooth settings on your device once you have the garage door opener plugged in. And you will just go to Bluetooth, and in our case this Bluetooth module is called HC-06. So you will press that and then enter the passcode, which by default is 1234, which can be changed later if desired. So once the device is paired, you can just go to the garage door opener app, which can be shown here through the Mun Engineering logo. And this section of the app was added in case you did have more than one garage door opener. So you just click, you click connect device, and then here will be a list of Bluetooth devices that are paired with your mobile device. So in our case, we just have this one, so we'll connect this, and once we press that, we will see that the blue light illuminates once we have successful connection. And also on the app, it is now displaying connected instead of connect device. And to show that this now works, I will just get both of this in frame. And by pressing open or close, it will send the short pulse, which can be seen by the LED lighting up. So just pressing that will open and close the garage door, which again is 250 milliseconds, which is a short enough pulse to actually turn on or off the garage door motor. So as seen in this early version of the app as well, we also have a disconnect button in case you did want to disconnect from this Bluetooth receiver and say connect to another one, or you just wanted to disconnect to it altogether. So once you press this, you will see that the blue LED turns off, and also the Bluetooth module flashes, which in the final stage of this project you won't be able to actually see this, which is why the blue LED is used. So now we have the garage door opener device actually hooked up to the garage door through these two wires here. And as explained in my previous documents, these two wires connect directly to the motor itself. And when they touch together or short together, that short pulse actually is what opens or closes the garage door. So when this relay closes, it'll send that short pulse and then turn the garage door motor on to either close or open it. So as explained before, the relay is connected the exact same way, except we removed the LED that was used for demonstration purposes. And we're still using the breadboard here just to show the circuit. And right now I'm using my laptop to power the device, but in the final version it will obviously be powered by either a battery or just connected directly to a wall outlet. Know that the device is connected by the blue LED illuminating. And once this is done, you can simply just click the open or close button to open or close the garage door. So I will show that now. So clicking open will open the garage door, clicking it again will stop, and clicking again will close. So the stopping and The stopping between the open and close will depend on the garage door model, but this device will function for various models that use this principle of the two wires shorting, acting as a pulse to open or close the garage door motor. So as mentioned in the document and as shown in the demonstration with the LED, the garage door can be operated without the smartphone or Android device by just pressing this button, which will then do the exact same thing while they're opening or closing it. Pressing the button again will stop it, and then pressing it again will begin to close the garage door. So like I said, this allows for manual control in case a device isn't present or you just want to operate the door without a device.
So in this step, I'll be going over how the app for the device was made. So the mobile app was created using MIT App Inventor, which is a free-to-use mobile app development environment. So I first started off by using 3 buttons, one being a list picker, one being just a regular button, and then the next being a regular button. So what the list picker allows to do is it allows you to choose which Bluetooth device you actually want to control through the app. This allows for the user to control multiple garage doors at once if desired. The button 2 is a simple disconnect button, which just disconnects the device from the Bluetooth module. And the button 1 is the open close button, which actually opens or closes the garage door. The GUI for this device will be changed in future iterations, but for now, in the prototype, it is just a functional app with not much visual appealing aspects to it. So we'll head over to the blocks to see how the app actually works. So when you press the list picker, it will bring you to a selection screen of all your Bluetooth addresses that are paired with your mobile device. From here, you can select which device you want to control through the app. When you select a device, it will connect, and the connect device button will change to connected so that it indicates to the user that the device is actually connected. Then the app will, or your mobile device will send a 3 to the Bluetooth module, which then will communicate through the Arduino through serial communications. And when the Arduino sees this 3, it will illuminate the blue Bluetooth LED indicator. The button 1 is the open close button. So this is pretty simple. So as you actually just press the button, the mobile device will send a 1 to the Bluetooth receiver, which will then send the 1 through serial to the Arduino. When the Arduino sees this 1, it will open and close the relay to send that short pulse, actually activating the garage door motor. And lastly, the Bluetooth disconnect button, which is button 2 here. When you click that, it will send a 4 to the Bluetooth module, then through serial to the Arduino. And when the Arduino sees this 4 through serial, it will turn off the Bluetooth LED, indicating that the device is now connected, or disconnected, sorry. And then we will call the Bluetooth client to disconnect, and then we will set the list picker back to connect device as it was previously set to connected. So here's the code for this working prototype. So I start by defining the pins for each of the components connected to the Arduino. So we have the relay connected to pin 13, the button connected to pin 2, the LED to pin 8, and then I define a char called value, which I just initially set to 0, which will be the value received from the Bluetooth module. So then we move to void setup, and here I define the inputs and outputs and also begin the serial. So we have the relay set to an output, the button set to an input, and the LED set to an output. Then we move to the void loop. So I start by defining an integer called button state, and this is just to get the state of the button by using digital read and then followed by button. And then since the relay is active low, meaning that when the relay is set to high, it is in the open position, I initially start the relay in the open position by setting it to digital write relay high. The first if statement is to close the garage door manually using the button. So just when the button is pressed, so when the button state equals 1, we send that short pulse. So we open and close a relay with a 250 millisecond delay between the open and close state. Next, we move to the second if statement. So we check to see if anything has been received through the serial terminals. And then we set that char value to the serial.read, which will read the value that has come from the Bluetooth module. And then we print that value. And then we move to the third if statement. So if the value is 1, as explained in the mobile app code environment, we will open and close the relay, which will send that short pulse, causing the garage door to either open or close. And then we serial print 0 so that the code doesn't continue to execute this if statement. Next, we have an if statement and an else if statement. So if the value is set to 3, so if the Bluetooth module sends a 3 through serial to the Arduino, we will know that the Bluetooth has been successfully connected to the mobile device. So then we will indicate this to the user by setting the LED to high, so turning on that blue LED shown in the demonstration. And then we have if the value is set to 4, meaning when the Bluetooth device is disconnected from the module, we will set the LED to low, indicating that the mobile device is now disconnected from the Bluetooth module that is connected to the Arduino.